Hi, welcome to Narcolepsy Pumpkin. I'm Andy. If you haven't done already, why not click on subscribe and then click on the bell so you get notifications when I post new videos. So what I'm going to do here is use the Asterisk tower kata that we did in the last video, and I'm going to use that as a starting point and then demonstrate how we're going to do dependency injection. So it's not going to be a complex dependency injection. What I'm going to do is actually inject make the star and the space for the padding and the actual asterisk to build a tower to be injectable as config. So I'm going to start here by actually adding a new project, and this is going to be a project that's going to hold the actual implementation. So I'm separating the tests from the implementation, which is something I didn't complete in the original test-driven development example. So what I'm going to do now is do this the old kind of fashioned way. So I'm going to literally cut and paste that class into the new project, which is a bit crude, but sometimes the old ways are the best. Just going to change the namespace using the ReSharper refactoring tools, and again you can see that it's lost its connection. ReSharper is intelligent enough to join it all back up again for you, so it'll automatically add the references and add the using statements in for you. I'm going to rename this because I'm not quite happy with what it's kind of called at the moment. So let's just rename that again, and we'll call it extension functions. So now we've just got a tidy separation between the set of tests and the what's now an implementation. So the entry point into this is a static function called create asterisk tower, and we're using these bits of config down here. So we're actually using a star and a space, and they're hard coded at present. So the first thing I'm going to do is make those still hard coded, but let's move them into the same place. So I'm going to introduce a constant. Again, this is using ReSharper, makes it quite easy to do this stuff. We're going to call this new constant a brick. And we're going to do exactly the same thing with the space. So again, introduce constant, call this padding, and there we go. It's also suggesting a name change, so while we're here we'll do that. So we haven't changed a huge amount, we've just introduced a constant with these two variables. Oh, sorry, not actually variables, we've introduced a constant for these values. Now just make sure all the tests still run, and they do. So that's a true refactor in that we haven't actually changed any behavior, we've just tweaked the implementation a tiny bit. So now I'm going to basically copy this set of tests. So I need another set of tests that's exactly the same as this set of tests. The reason for that is because I want a set of tests that test the same tower exactly, but with different characters representing the brick and representing the padding. And we call this test with alt config because that's what it's going to be. And I'm going to change these to hashes. So change all the stars to hashes. 3 there, 1 here, and 3 here, 5 here, and again a single, 3, 5, and finally 7. Okay, so we've changed all the bricks, so that's half the config. I'm going to change the padding to a dash. Let's quickly go down all these. Oops. This probably isn't the most efficient way of doing it, but hey. So we've got a new test. Effectively, we know it's going to fail, so that's a given. I don't need to run the test to prove that this fails, because currently the config inside is hard-coded. So I've got to change enough of this test just to include some sort of config that we need to inject. So in some respects this is wandering off a little bit from sort of true test-driven development, but the ethos is still there. So I'm probably changing a few too bigger chunks in one go, but hopefully this should show the process of going through it. I'm still going to do it in stages. I'm still going to use a lot of the inbuilt resharper tools as I've done here. So I've created an interface for iConfig, which is going to be the interface with the 2 definitions of the brick and the padding on it. Now I'm going to introduce, well, initially a NuGet package that is one of my own. If you've seen the Shadowquack videos, so we're going to use Shadowquack, which is a nice quick way of dynamically implementing an interface without having to do any of the concretion stuff. So it kind of makes C# a little bit closer to dynamically typed, which, as long as you got unit tests around things, you shouldn't run into any problems. So to use that, I'm just going to say duck implements and then iConfig, and I'm just going to pass in a new empty dynamic object. So there we go. We've just changed it to var because we don't need to define that type now, because that's what it's going to actually return. So in iConfig we need a brick and padding. So those are 2 things that we need in our config. So nice and simple. So I'm going to add those into the interface. The chars. So they're a single character, not a string. So that's brick and padding in there. Notice these are get only, so there's no setters on these, they're completely immutable. And basically using Shadowquack we just add in brick and tell it to equal a hash in this case, because that's the config we're expecting. And padding to equal a dash or hyphen. So there we've got quite quickly we've got that iconfig populated instance of it with a hash and a dash. So the next thing we're going to use is another NuGet package of mine, which is Dependency Shelf. It's just a really, really simple way of doing dependency injection, which just basically uses a singleton. There's nothing complex about this. It doesn't do any, automatic injection of parameters on newing up classes and things. It's not to that level, but it allows you to understand and use the concepts of dependency injection using a very simple concept driven. So what we're going to do is use shelf, which just shelves an instance of an interface. This only works with interfaces. So dependency shelf, if you try shelving a type that is not an interface, it will error. So you always have to, it's good practice when using it to always have that interface defined in the generic, whether your return object is actually returning an interface or it's turning an actual concrete implementation of that interface, just to make sure that it's clear what you're doing. Now the other thing I'm going to do in this is I'm going to create a gateway class, and this gateway class is going to be there just to hold the interfaces. So it's the common part between the tests and our implementation of the actual shadow tower generation functions, so the extension functions. So we've got three things separation. So all the dependencies are pointing to the gateway is the intent. So the asterisk tower is going to be using iconfig. I just need to change all these just so it's pointing. We're just changing the dependency so it's pointing at the gateway. So that's done one side of it. We've shelved it. We can just pull that in line. So now the bit we need to look at is how we get our implementation side of it to use that config. So we just tip over to our extensions again, and I'm going to change this to use the other half of the dependency shelf. So we're going to say shelf.retrieve instance. Oh, sorry, I just need to change this to a static. So shelf instance we've used already, and retrieve instance pulls the instance back off the shelf. So the reason it's called dependency shelf because it is basically like you putting your dependency on a shelf and then be able to reach up and pull it off wherever you want, from wherever you want in your code. So you put it on the shelf right at the beginning and pull it off from any point in your code. Let's do the same with the padding. And that's basically it. We've changed this so that now it's not using a constant, it's using the injected config class to represent the brick and the padding, which are down here. So we should be able to run this now, and this should pass, and it does. But we've broken it because now our original test fails. Now, original test fails because we haven't actually injected any config. So what we need to do is change this to statement body, and we're going to cut and paste this for now. We can always tidy this up in a refactor later on. So quick and dirty to start with, get it working. And it's a space and an asterisk, and now that set of tests should run. So both test sets of tests run, but when we run them all together we get errors. And the reason we get these errors, you actually see that it's actually using a hash down here. So it's picking up a set of config for the first test. It's using the config that we passed in for the second test. So the only test that passes is the ones that has 0 rows, because that's always going to return an empty array. If we run that set of tests independently, it works. If we run this test independently, it works. Now the reason this happens is because those tests are running in the same app domain within the .NET framework or the runtime. So the quick way to solve this is to clear the shelf at the start of each set of tests, and there's a function in there called shelf.clear. So now if we run all those tests together, they all pass. Now normally in runtime you don't need to do the shelf.clear unless you're doing something strange in sort of switching out dependencies during runtime. Usually you just inject them all at the start and then you run with those dependencies all the way through your application. But for the purpose of test, the shelf.clear is very useful. You can also clear an independent instance. So at the moment we're just clearing the whole shelf, so we're literally sweeping all the books off the shelf. You can just go and pick a particular item off the shelf, so shelf.clear instance will do that, and you can just throw that away. So we're just going to add extract this into a method just to refactor it. Now we've got all the tests passing, so we get rid of some of that duplication. So we just create a function that effectively clears the shelf and puts our dependency config on, and we'll pass that dependency config in as just 2 char characters. Sorry, 2 char parameters. And then we're just going to basically quick and dirty just use Control W to select the bits we want. Oh, gone too far. No, no, no. Control Z is your friend. So I was going to say is use Control W just to get the total of this block, and then we're going to paste in and change the parameters to a star and a space. So there we go. We've sort of tidied that up a little bit, and we've got 2 tests. I don't think there's anything else we can really. I mean, we probably could put it all into one theory, but that starts to cloud the reason you've got these 2 sets of tests, because one's kind of testing that you can inject different config. We just rerun that top set and rerun the second set, so we can do Control UR, we'll run the tests. There we go. So just to recap what we've actually done, so we've introduced this interface, which is now in an Asterisk Tower Gateway project, and we're going to use that, so everything points to that, and we're creating an instance dynamically of that using Shadowquack, and we're then using it inside the extensions. So that's giving us the config dynamically injected at runtime. And that is the basics of dependency injection. So we haven't quite finished there. What I'm going to do is add another project to this solution, and we're going to make that a console application. So we're actually going to use this Asterisk Tower extensions in an actual runnable app, so we can see how we inject those dependencies in a runtime environment. So we've done it for tests, so now we need to look at doing it in an actual runnable application. So we're going to get rid of the hello world, because that's not what we're doing here, and we need to look at somewhere where we've got an example of our implementation. So that's where the tests are very useful. We've actually already got something that has an example of how to do this. So I'm going to roughly grab, well, actually we don't need the asserts, we just need the create asterisk tower. So this is a rough implementation. Let's chuck that into the main here. Okay, it knows nothing about most of this stuff. We've got an inject config dependency function, so we can go and kind of pinch that from the tests. So that's what we're essentially doing. Is shelving an instance of a brick and padding. So first thing, use resharper. Just undo my random typo there. So use resharper to pull in the shelf dependents, because it knows they're already in the project elsewhere, sorry, in the solution elsewhere, so it's able to pull those in. Again, you can just put in the reference for iConfig, it knows that that's in our gateway class. Duck, I've used it before, says shadow quack, so I can pull that in. I'm not having to do a lot, we don't have to go and reinstall the NuGet packages for this, because it knows we've already got them as part of the solution already. So just introduce a couple of variables. So there we go, we've got variables for the brick and the padding, and do the same thing for rows. We know that's an int. So we can just put actual values in for these. So just hard coding it to an asterisk and a space. And we're going to do 10 rows. So one of the things I don't understand about resharper, when you've got an extension method, it doesn't always pick up where that belongs, so you have to go and actually just add in that project dependency manually. So there we go. So obviously we need to output that tower. So using the string join function, and we want to join it with a separator of, well, carriage return. So that's /n. The slash the right way would help. So that gives us a single string with a carriage return separating the rows, and then we just write that out to the console, nice and simple. So that's just write and tower. So this should run. So first thing we need to do is make this the actual default project for the solution, so that it's the one that actually runs. You do that quite easily by right clicking and clicking on set startup project. Now run asterisk tower CLI. I'll just pull that in here so you can see it's run 10 rows, create a tower, output it into the console. So what I'm going to do now is add another NuGet package. This is another one of my NuGet packages, and it's a new addition to the Shadow Quack set. And it's an implementation that allows you to use command line arguments as an input into the Shadow Quack. It's a very new package. It's kind of only beta really. It's fully working, though may have some quirks in it. And all that is an implementation of the proxy. So it allows you to proxy a array of strings in a kind of command line argument kind of way into Shadow Quack to allow you to put those values into an interface. So first thing I'm going to do is we need to create another interface, because this one for iConfig is only for the brick and padding, and we want to have rows in there too. So I'm going to create a new interface called iCLI config. I'm going to make that inherit from the existing iConfig. So that now has brick and padding in there already from that inheritance. So we're going to add a rows integer in, and we're going to make that a get only property as well, so still immutable. And I put that in the wrong place. I need to put that the other side. So we're still shelving iConfig because that's the dependency we're injecting, but we're going to actually create an instance of iCLI config, and then we're going to get rid of this use of a dynamic object that's using those hard-coded values, and we're going to introduce the args proxy. So what we're doing is we're going to cast, so I need to put this in brackets. So we're casting args implicitly to args proxy, which is fine. That's what it's designed to do. The other thing we need to do is pull that out into a variable, because we need to use that config down here for the rows. So instead of the rows hard-coded value, we're going to use the rows as part of our new config. So now we can get rid of these unused hard-coded parameters. So we've got a config that's been pulled in from the arguments, and then we're writing that a tower out based on what we're passing in as command line parameters. The thing we can do is we can pull this out into a class just to tidy it up. Sorry, pull this out into a method just to tidy it up. So we're going to call that draw tower from args. I'm actually going to rename that because I don't like that. Draw tower from config. There we go. So we can pull that in line, so that's fairly tidy, and we can actually pull that tower in line as well. So I've actually got rid of all the variables that were kicking about, and we can put this into its own. The other thing, it needs to be public, otherwise Shadow Quack will struggle. And move that into its own file. Now to be tidy, we're going to put that into the gateway class. So again, old school, cut and paste, shove it into gateway, and we're just going to change the namespace. Everything should be okay with that, because because it's already pointing towards gateway, so it should just pick up that's where it is, and it does. We're fine. So that's it. This should now require some command line parameters. For the purpose of debug, we define those here, so in the debug section, and we can type the parameters in. Now the parameters are, so we give it the name of the variable we're going to populate, a colon, and then the value. So we've got slash brick star, then slash padding colon, and because it's a space, we're just going to put it in quotation marks, and then we want the rows colon and just an integer number. So in this case I'm going to say 5. So we now run that, and then we get a nice pyramid of 5 stars and spaces. So if we change these, so the padding character is a 0 and the brick character is a 1, and we have 6 rows, we now get 1s and 0s. So we've now moved our dependencies onto the command line in effect, and that's getting translated into the dependency, which is then getting injected into the code. So we can also go and find the actual compiled executable. So we found that in the debug folder. We can run a console in that folder. So there we go, we're already in the folder. So we can now actually call that executable. So it's // which is convention for PowerShell, current folder, asterisk.tower.cli, and we need to pass in parameters, so brick as a hash, and padding can have an underscore, and then we can do rows 100. Crazy! So we've actually created something that's wider than the screen, and it's a bit crazy. So if we just run that again, rows 10, there we have a nice simple 10 row pyramid using the parameters that we've passed in. So that basically concludes sort of an example of injecting a very simple set of data as a dependency. So the packages we've used are Shadowquack, and we've used Dependency Shelf, and we've used Shadowquack Args. And these are all packages that I publish on NuGet. If you go to nuget.org, profiles, clean craftsman. You can also find the source for this on GitHub underneath the Asterisk Chapter, and it's the dependency injection branch.